Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. Are you ready? If you are ready, put number one.
Waalaikumsalam, Doktor.
Yeah. Put number one. If you are ready, put number one. Yeah. I hope that we can have two-way communication, of which I will discuss something, and I hope that you can um ask me what you think you can do. Maybe is that what you think is suitable or appropriate for terminology that maybe for some of you new, isn't it? Um, we have mean, mode, median, isn't it? Standard deviation in statistic, but new terms is coming in chemometrics. If you think that you don't understand, let me know quickly. Yeah. Or else you will find out that this lecture is a bit boring. Okay. If you I will share my screen. Yeah, I will share my screen. Okay. If you look at the chemometrics folder under CH2.2, there is a MATLAB folder, and I put one folder with the name notes here. You double click on it. Yeah. Um, I provide here the basic coding in MATLAB. Maybe it is important for you to look at it and uh, study. In the future, if you want to implement MATLAB, you can use this one. Especially for this MATLAB cheat sheet. Yeah. Okay, I double click this document there. Okay. So this is the basic terms that we will write and we put as in MATLAB programming. Yeah? CLC, clear, CLF, close, all, doc function, command, control C, format short, format long, display text. So we will do some of this later while we are implementing or writing MATLAB programming. I do believe that you don't have to study in a very great detail of MATLAB, but knowing the basic in order for you to complete the assignment is important. Yeah. So go through this MATLAB cheat sheet as well as this one, MATLAB basic function reference. Yeah. Okay, look at this. What is the meaning of this coding in MATLAB? Okay, MATLAB stand for Matrix Laboratory. So we will think on how we analyze the data by looking at matrix operation. Okay, so that is why here we have operators in matrix form. Okay, if you don't understand, let me know. While you are installing your MATLAB, if you found errors or you are not sure what to do, you just simply can WhatsApp me and I will reply as soon as possible. Okay. Okay, I will continue with my slide, right? Um, just now, one of your friend asking me, isn't it? What is the meaning of data cleaning? Sometimes when you import your data into some other software, okay, say for example, you have chromatogram, you have FTIR spectra, you have IR spectra. Sometimes when you transfer the data, there is an error of not a number. Okay, you can see in Excel sometimes, isn't it? You can see the number 23, but it is not a number. It being recognized as a text. Okay, so when you transfer the data from Excel into another software, it will detect as not a number. So you have to replace with certain number, certain information, so that the analysis can be carried out. You understand? That is one of the meaning of data cleaning. All right. To proceed my session now in our next 1 hour, I will try to complete my next 30 minutes on my slide and the last 30 minutes on uh, reading materials. Reading materials. I will invite anybody who would like to share what have you read, yeah, and what you understand from that. Okay, I will go through one sample in 5 minutes later. So I hope that when you try to share your opinion on that particular paper, um, you will understand more. Okay. Now, next slide. Yes, slide number 13. Okay. So, what is the point of doing a chemometrics? We can see the pattern, isn't it? Can we see the pattern, for example? So if you have this question, meaning that you just want to explore your data, okay? If you want to see, is there any cluster? Is there any groups? Is there any class of the data set? You can use PCA or some other data uh, cluster analysis, yeah, like dendrogram, okay? So number three, if you already know you have two class of data, maybe a sample of um, cancer patient, a sample of um, uh, normal people, okay, normal patient, yeah. So you have the sample of urine, maybe you have a sample of raw material, which is grade A, grade B, grade C. You already know. So can we classify the sample by using chemometric method? Okay. Maybe you want, maybe you already perform the a wet chemistry analysis. You run the GC, maybe you run the mass spec, you get the chromatogram. But to get the quick answer of classification, maybe you can do chemometrics of what we call the metric is called data discriminant analysis, yeah? DA, discriminant analysis. All right. So number four, if we have if you have the large number of variables, yeah. So chemometrics can handle this by reduce which variables is important for certain situation. For example, you have a NIR spectra of cooking oil, for example. Yeah. So you have cooking oil grade A, grade B, grade C. Yeah. The spectra for the cooking oil NIR spectra is around maybe 2000 variables. Yeah. So you want to reduce from 2000 variables, maybe only 100 of them is important. So you can use chemometric to reduce and select the important variables that can classify type of or class of palm oil that you have, right? So number five, you have a sample of maybe percentage of albumin in urine. Yeah, in urine you have the sample of percentage. You have a sample of urine and you already analyze, and from the sample of urine you have a certain number of amount of albumin in urine. Okay, you get the spectra for the urine, and can you relate, or can you regress, or can you model from the spectra with the concentration of urine, or can you classify normal urine with the urine with problem patient? Okay, maybe the problem has a high amount of urine in albumin in urine, so that you can use maybe discriminant analysis, or you can regress, or you can predict the amount of albumin in urine. Okay, so that is the objective of chemometrics. So you have to see these ideas on the paper that I provide you in the folder. Yeah. From the analytical data, you have the information. Okay. So maybe the analytical data is the concentration of metal in blood, maybe, or the concentration of metal from your sewage. Okay. Or maybe the concentration of uh, uh, metal in soil, and you have the category of soil. Maybe the soil is good, is higher in pH, for example. So can you relate the analytical data with the information of or you have in your laboratory, for example? Yeah. No. Um, Now we are talking about chemometric dataset. So when you read any papers about chemometric, they will explain what the dataset that they are using, where the dataset is coming from. Okay. So we have two kind of dataset. One is from what we call wet experiment. For example, you have IR, you have UV, you have NIR, Raman, GC, mass spec, HPLC. Okay. You have another instrument to identify chemical content. For example, you have AAS, HPLC, GCMS as well, ED, XRF, and PIXI. This is just only an example here. Maybe you have your own instrument for wet experiment dataset generator. And sometimes we have dataset from dry experiment. If you are involved in a drug design, we have terms quantitative structure activity relationship. So this data set namely is coming from a certain number of software appropriate for drug design. Yeah, where they will identify for each chemical compound or molecules what is their bending energy, stretching energy, HUMO, LUMO, molecular weight, and many more. This is what we call the dataset from dry experiment. Actually, it's coming from software. Yeah. So quite sometimes you will find a paper that will combine these two dataset together. Okay. For example, you can run an experiment to detect bioactivity, for example, hypertension, anti-depression activity, for example. Yeah? So you run an experiment to identify which compound that help to eliminate or reduce depression. Okay, you have the data. This particular chemical compound has anti-depression property. This value, that value, this value, for example. Yeah, and you run another experiment to find out what is the information from the molecular structure. So can you relate from the chemical structure with the biological activity? So most of the time when we dry experiment, we will combine with wet experiment data set. Okay, so far so good. Is there any question? So far okay. Is there any question you like to ask for number one? If you're okay. Okay. Next. Okay. If you want to do your master's project without going to wet experiment, you can do this QSAR. You can Google QSAR. You can get the experimental activity from wet experiment, and you can do a dry experiment to develop the prediction of molecular activity. Okay, you can Google. I give you here the reference, and you can search a lot number of software or the paper that I provide from this slide. Okay, so this is what I'm doing when I did my master's 20 years ago. I don't need to go to wet experiment. I just concentrate with dry experiment, but the data set from wet experiment is available from certain database provider. So just combine the data set with my dry experiment to come up with QSR modeling. Okay. Now, what are the software to generate descriptors? What is molecular descriptors? Yeah. Molecular descriptors is the information that you can gather from molecular structure. For example, if you see methane, yeah. For example, methane has 1 carbon and 4 hydrogen. So 1 and 4 is called a descriptor, okay, or molecular weight as a descriptor. So there are a lot number of softwares that can be used to generate molecular descriptor. I put it here, okay. You can Google or you can ask ChatGPT if you want to, Copilot, if you want to know more what is molecular descriptor. Okay, right. If you already have data set, what you wanted to do? Okay, first of all, you have to clear in your mind if you want to do chemometrics, what kind of data set that you must generate or you must have. Okay, so if you just want to get the cluster or you want to see the integrity of the data, you just can use chemometric to explore your data set. So maybe you can plot in 3D like this, or you can see there are two groups, yeah, of data set. Or you wanted to classify whether you can distinguish between red and blue. So what model should be used to draw the line between red and blue? Okay, this is what we call classification. Okay, so in order for you to do classification, there are a lot number of methods available. How to calculate to classify this. you can do Euclidean distance, Mahalanobis distance. You can use support vector machine. You can use KNN and many more. This is just only an example. Yeah. Or you have the what we call it, the activity of one particular set of molecule. Maybe you have toxic city value, you have hypertension value, you have antioxidant value for certain chemical compound. You want to develop the model, okay? You can do regression. So in order for you to do regression, there are a lot number of methods as well, but in chemometrics, normally we will do MLR, PLS, and PCR. Okay, so further reading, you can look at my reading folder here if you want. Okay, or you can explore yourself by using AI or what chemometrics can do in regression. Yeah. All right. So what is the meaning of exploratory? Exploratory. Okay. This plot is coming from my PhD thesis. Yeah? I receive a data set and I try to plot the data. Right. So if I simply plot the data based on years, yeah, I received the data in 2003, 2004, 2005, 2006, 2007, and put a label on it. And I use PCA. I'm not able to see any distinctive groups. Yeah, but when I look at the dataset again, I ask the our collaborator, okay, our collaborator. So tell me, give me the dates. Okay, firstly they give the year, okay, and later they give the date of the uh, the the data has been analyzed. So what we got is interesting. Yeah. So they analyzed the data in 3 batches. Okay. One is 2003, 2004, and 2004, and 2005, 2006, and 2007. So I put uh, the color based on batches. Now you can see quite clearly that they are distinctively different because of batches, not because of the years. So this is what we call exploratory. We can explore, we can try to look at the data. Is there any cluster? Okay, is there any group? Okay, that
Sorry,
are present
doctor.
in the data set. Yeah.
Doctor, I'm not quite understand how the batches are giving a different output, doctor.
Okay. Now, certain number of sample that you want to analyze is subject to radioactive decay.
Mm-hmm.
Yeah. Okay. Wait. Subject to radioactive decay. Okay, maybe you can collect a sample in 2003 and 2004. Yeah, I try to give the situation that we have here. Okay, I try to make it bigger. Okay, so you have no choice. When you collect the sample, you have to analyze the data at that particular time by using that particular instrument that we have, the technology that you have in 2003 and 2004. And you run another experiment, you collect the sample, but now you have new machine, you have new idea, right? So you have to run it in another year, 2004 and 2005, this one. Okay, then you run another, sorry, first 2003, this one is blue, isn't it? And later you got the red one, and later you get the blue one. So different, maybe they will they analyze the concentration of the metal. This is the concentration of the metal, yeah, in 2000 3 and 4, 4 and 5, 6 and 7. They have to analyze it at 3 different times because it is 3 years already, isn't it? For in 4 years data set. So when they combine the data set into one, so if you want to see the trend, definitely the trend is different because they has been analyzed at 3 different times. In chemometrics, we call it data drift. So it is due to the time or the time when we analyze the data. Are you okay? Are you clear with that, Pavitra?
Actually, not very clear, doctor. Because, doctor,
Yeah.
I've been working with this PCA also, but actually
Yeah.
not in very detail. What we
Mhm.
have done, doctor, we collected some palm oil from different plantation, something like that, and we
Okay.
run the analysis, and then we
Yeah.
try to see the difference between the plantation, doctor.
The difference between the plantation.
Plantations, yes, the
Okay.
oil
Good.
that we collected from the plantation. So the
Okay.
data is the same where it will collected all in the zero, and then when
Yeah.
it's dispersed, doctor, we can see some data on the top and we can
Mm.
see some data on the right and left. So
Okay.
that's why I'm a bit how interested to see how to read this thing, doctor.
Okay. Good. Okay. Now again, uh, you, I think in your case, you already control your data set generation because you just received the sample of palm oil, isn't it?
Yes,
And
doctor.
get the spectra on your own. You have fixed instrument.
Yes.
Okay. So I would suggest you you try to run on different instrument.
Oh,
So I do believe that you will see the different like this because
okay.
different instrument will give you different wavelength, different sensitivity,
Mm,
different LOD,
mm,
different amount of spectrum, isn't it?
mm.
Uh,
Yes, doctor.
so okay, so that is why when you want to discuss something about data analysis when you do chemometrics, you have to make sure that your data set is in control, meaning that you are having same sample, okay, palm oil, okay, you have the same you understand the genetic of the plant that you get the palm oil from, okay, you fix the instrument that you generate for the spectra.
Mm.
Only then you can see this trend. Or else
Okay.
maybe the drift or the cluster is not based on the quality of palm oil, but the quality of the instrument.
Ah, okay.
You understand?
Yes, doctor.
Yeah, yeah. Because
Mm.
I have one research a long time ago where I get the spectrum for palm oil and non-palm oil. Before your very eyes, the color, the type of the palm oil, yeah, palm oil and non-palm oil, almost the same, isn't it? But
Mm.
when you run PCA, definitely they are different.
Yes, doctor.
Okay, you believe me, yeah? Because you already
Yeah,
deal
yeah.
with, yeah, palm oil and cooking oil. I gather lot number of cooking oil and I gather lot number of palm oil. They are distinctively different. Even
Yeah.
from the spectra, they are almost the same. So this is the powerful of exploratory data analysis, especially if you use PCA.
Mm.
So that I would suggest you any sample that you get, you must have full information. Who is generating the sample? Okay, what type of instrument that they are using? When they analyze the data, get the date. Who is the person who is generating the sample, the spectrum? You must have this
Mm.
detail, great detail, so that when when you want to make a conclusion, you have a very clear that the cluster that you see is coming from this situation. Sometimes you want to
Ah,
prove something, isn't it? Say for example, yeah, I just give you some idea. Say for example, this is cooking oil, and then out of sudden the red one is the good one, isn't it?
mm.
The good one. But actually, the good one is not because of the quality that you're looking at. This because of the spectra is being generated from this instrument.
Okay, doctor.
Ah,
Mm-hmm.
okay. Yeah. So that
Mm.
when you want to do PCA, you must have a very clear information of the data set that you have. Try
Okay.
to include as many information as you see. Right here in this case, I was stuck while I doing my PhD. I do believe that this data set is coming from years, but it is not coming from years. The cluster is coming from when they has been analyzed. Actually, this data set is coming from environmental pollution, and we detect the concentration from air. So it is subject to radioactive decay, so that they cannot keep the sample for a long time. They have to analyze for certain number of years. After that, they will throw away. So therefore, I can conclude that I have this. I was stuck for this analysis around 3 months and 4 months for this data set. I don't know what to do. So I discussed with my supervisor, and I told him that this is the situation that we have. Okay, we have a discussion, and then we proceed with another data analysis. Okay, Pavitra.
Okay, doctor. Thank you.
Good. Thank you for asking. Okay, so that what I can conclude that from the data, if you use chemometrics, you will get information. Okay. Again, I want to emphasize that maybe you can optimize your experiment and save money. You can predict the origin of the chemical. You can understand the pattern of the data. You can classify the impact of the data on the environment, for example, bioactivity, toxicity. And for drug analysis, we can predict the future of chemical compound. Yeah. All right. Okay. I already complete my slide for 30 minutes. Right. Um, Now I open the floor for anybody who would like to give your opinion or give your summary, give your suggestion of what is being carried out by any reference that I put on reading one. Okay, anybody? I will jot down who is participating this process so that in the future better assessment can be made. Yeah, just pick one paper.
Doctor, can I start?
Yeah. Yeah, good. Which paper?
Doctor, I took the application on the chemometric method on the environmental analysis.
This one, yeah.
Third one, yeah.
Kanan. Yeah. Okay, I open it. Okay, good paper. This one quite good. You know who is this guy? Roma Toller.
No.
No, he is the chief editor of Journal of Chemometrics and Intelligent Laboratory System. One of the important journals in chemometrics. We can Google his name, Roma Toller. Okay.
Okay, doctor.
All right, go.
Doctor, why I choose this topic, doctor, because it's about the environmental analysis, which
Okay.
myself also are working with the pesticide residue.
Yeah.
So there is two things they've been talking here, doctor, about pesticide and also the PAH.
Mm-mm.
So I took pesticide for my understanding, doctor.
Okay.
So they have how to say explain that this chemometry can be used for three types of analysis. First, for quantification. Second, they can use for the environmental quality analysis. And
Yeah.
third, it can be used to predict the toxicology effect for from the structure or what we can predict what is that. So to be more understanding, I choose the quantification of the pesticide.
Okay.
So actually, I've also been working with some of the chemometric method like PCA just now, doctor, I have mentioned to you. So
Okay.
in this journal, they talked about the two type which I never heard before. This is my first time I'm hearing about it, doctor. It
Mm.
was just a minute, doctor.
This one.
MCRALS and also pa-
Perfect.
Parafect,
Yeah.
MCN Parafect.
Okay.
This is they consider this as a second order calibration where
Yeah.
they use this to for a complex data where there is a lot of data for one. For example, now is the pesticide. We know
Yeah.
pesticide as a if in for example, if it's in the water or if it's in the oil, it's have a lot of contamination, or we can say it's a lot of interference. So I
Okay.
think they use the second order calibration because it can be give a accurate result with
Mm-hmm.
this different signal or with a different instrument or with a different intensity. It can
Mm-hmm.
give a accurate result without any linear, even though there is no linear how to say, doctor, linear data, it still can
Okay.
give us the correct data when we use the software, doctor.
Mm-hmm.
So I think uh, and then they use a multivariate calibration technique in the journal, and I have seen that type of method in most of the journal also, doctor.
Yeah. Okay.
That's all, doctor. Thank you.
All right. Thank you. All right. Okay. Let me try to explain to you the first one. Yeah. What you call it? Uh, yeah. Wait. 2.2. Let me try to go to table of content. Quantitative radical dependent pesticide 2.1. 2.1. Where is 2.1? Okay, pesticide. Okay. Yeah, we have they have a lot number of uh, methods of how to analyze the what do you call it, the molecular activity of the pesticide or the content of pesticide. Yeah, yeah. It's X1 method. This one is X1 advanced, quite advanced method. But for me, I'm familiar with PLS. Yeah, yeah. All right. Good. Good. Presentation from Pavitra. Is there anybody who would like to discuss something? This is a review paper, isn't it? Review paper is quite extensive, but you are not getting much on detail on certain method. They just give a general ideas. What is this method can be used? Okay, okay. Any more? Just pick another paper, one paper. Just explain to everybody what you have uh, read.
Can I try, Doctor?
All right, good. Which paper? Oh, yeah.
I picked a review of chemometric models to predict crude oil properties.
Wait. Review of
A review of chemometric model to predict crude oil properties
this one, yeah.
from NMR and IR.
Okay.
Yep, that one.
Okay. This one I'm not familiar with uh the author. Okay, now what do you want to say?
Okay, so basically I picked this article because I used to work in a refinery um, company,
Yeah.
which is specifically in palm oil.
Mm-mm.
So basically, this paper they wanted to test um, some of the chemometric models to predict crude oil properties
Mm-mm.
through these analytical techniques, which is specifically using nuclear magnetic resonance (NMR) and also IR. But for NMR, they chose both type, which is proton NMR and also carbon NMR. And
Mm.
they wanted to test crude oil properties such as API gravity, kinematic viscosity, and also heavy metals, for example, sulfur.
Mm.
And basically, the objective of this paper, they wanted to review various chemometric models to
Mm.
predict these parameters,
Okay.
and they found out that the models, is it a model, the PLS is a model, doctor?
Regression method.
A method. Okay,
Ah.
so they have various methods that being tested. For example, partial least square regression, which is PLS,
Mm.
multiple linear regression (MLR),
Mm.
principal component regression (PCR),
Mm.
and SVR.
Mm.
But out of this paper, they found out that um, the PLS giving the most high accuracy
Mm.
um, while developing the data, the regression.
Regression model.
Yes,
They
because
they want to predict the properties here, isn't it? The properties.
yes,
Okay, good.
and so this paper highlight that the density parameters is the most frequently predicted property, which is they achieve the model with a very strong correlation coefficient.
Okay.
And also, which I mentioned before, they suggest that PLS regression is the most commonly used method, and they also suggested that they need more study that utilizing the non-linear method and also the carbon NMR to fully leverage the potential of chemometrics in crude oil analysis. So basically, what I learned from this paper is that um, there are several regression methods that we use, but PLS is the most used one,
Mm.
other than PCA and also MLR.
Okay.
So yeah, that's all.
Okay. Good. So we have here the sample. Okay, the sample that we are talking about in this paper is crude oil
Crude
properties.
oil.
Sorry, crude oils. Yeah, crude oil. The sample is crude oil. So the properties that we are looking at is this one: epigravity, kinematic viscosity, and sulfur content.
Yep.
What they wanted to do is to predict this activity, right?
Yep.
So the activity for this crude from oil, this crude oil is coming from different methods as
Yes.
listed in table 1.
Yep.
Okay, you have
Yeah.
oils and you have method to predict the activity or the
Properties. Yeah.
property, right?
Yes. Yep.
Okay. So they want to model the property of this crude oil by using the spectra
Mm-mm.
or the data set,
Using NMR and also IR
NMR
spectroscopy.
and nuclear magnetic resonance. Okay. So they are performing regression by using partial least square. Okay. Good. Good. Good selection of paper of what you.
Doctor,
Yeah.
I have another question.
Yeah.
Since my role previously, I was working with data as well.
Mm,
I did develop some calibration curve for FTIR because back
mm,
then our lab was trying to bought a new FTNIR, and then of course we need to set up some data in the software, right? But then while developing the calibration curve, I experienced with PLS and PCR, but then I didn't know what that means because it's just the application scientists that suggest me to use these models.
What
And then
software that you use? What software that you use?
um, as far as remember, because it is from Perkin Elmer, so it was
Coming from
Spectrum.
the software of the instrument.
Yes,
Okay.
yes, software the instrument.
Okay.
So I was experimenting between PLS and PCR, and yet both of the models give like different R squared value, and
Okay.
believe that the application scientists suggest to choose the highest R squared values.
Yes. Yes.
Then because we use the same data, but then still slight difference between the PLS and PCR. Uh, I mean the R squared value giving the different values, even though, so I mean meaning that does these regression models actually will affect the value even though we just use the same data set.
Yeah. Of course. Different data, the same data set, different calibration or regression method will give you different output because
So
the program behind it is different. The algorithm is different.
so how can we decide which one is better? I mean between PLS and PCR.
Most of the time, PLS is better than PCR in most of the situation.
Oh, I
Okay,
see.
because of the algorithm in PLS include the information from the data set, from the one that you want to predict. Later, I will explain when we arrive on the particular section. So please let me know. I will highlight this again when we go to MATLAB MATLAB workshop or MATLAB class later in our next class. I will explain the difference between this PCR and PLS.
Okay, Doctor.
The only difference is that they are in PLS, we are incorporating the value of y that we want to predict into our model. So that is why we get better.
I see.
Okay.
Okay, noted, Doctor.
All right. Thank you.
Thank you, Doctor.
Good. I feel interested in your work. Yeah. Wait. Okay. This is the properties or physical properties that we want to predict. So the method that we use to predict the dynamic viscosity, power point, okay, right, total sulfur, and many more. And some people use NIR as well. Okay, NIR, Raman, SUV. This one I'm not familiar. Okay, NIR, proton NMR. Okay, okay. Let me see the result. Let me see the result. Is there any result that we provide here? Wait. Okay, conclusion. Okay, all right. I'll let several variable. Okay, they apply. No, PLS can deal with a lot number of variables, especially NIR, Raman, Proton, NMR. But we have to apply variable selection technique as well. Okay, so what is variable selection technique? So out of 1,000 or 2,000 variable, we may want to choose only 100 of them, which is significantly important for our model. The rest is just only a noise. Okay, let me see the result. Is there any information on the result? Oh, this one they mentioned about the article presented. Yeah, okay. Okay. If you want to see in a very great detail, maybe you can see the paper that they are discussing. So this paper is review paper, yes. Yeah, review article. Yeah, good. So any more? We have one more. Last one.
Can I try, Doctor?
All right, good. Ayuni?
Okay, so basically, I'm just want to make sure my understanding is correct, lah, Doctor.
Yeah.
So basically, I'm referring to the paper. Wait, application of chemometrics in oil spill study.
Yeah, okay, wait. Which one? Wait. Application of
Chemometrics in
what?
oil spill study.
This
Yeah.
one.
Ha.
Yeah, yeah, I will open it.
Right.
Okay. Review. Yeah, okay. Let
Yeah.
me check the author. I don't. I'm not familiar with this. Okay, go.
Okay, so basically, this paper referring to the oil spillage in the seabed. So basically, from the oil spillage, we cannot know what is the type of the. As we know, petroleum is basically complex mixture, right? Contain many organic compound in there. So when there is a oil spillage, we cannot know what is the type of the compound. What is the type of compound is contaminated. So basically, from this paper, I'm just learned that there are many types of chemometrics that are available, which is we can divide into three parts. Design of experiment (DOE), which
Yeah.
is in the table one, which is in the table figure one, Doctor, figure one.
Okay.
So basically, as you can see from this figure, there are three types of DOE, multivariate analysis, and then multivariate analysis. So from you can, as you can see from this table,
Mm-hmm.
we can know that on 1990, the using of the multivariate is getting higher due to the our power of the computational getting increased. So
Yeah.
basically, there is a study. So basically, from this oil spill study, there is a study by the Ismail. There is a spillage in Peninsula Malaysia and in Sabah. They
Mm,
collected 94 sample of oil spillage. So by using the PCA and the HRA, they can group or classify this oil spillage into four group. Okay,
mm. Okay.
which is
Which part that you are saying this one? Which part?
in page 5.
Page five. Okay. Wait.
Mm-mm.
Page
Page
five.
5. Okay.
Page five. Wait. There's three. Wait. Four.
4. Uh,
And wait.
okay,
Four.
5. The one, Ismail. Ismail
Yeah.
et al.
Okay.
The first bottom one. Mm.
Page.
Page 5.
This one is page five. Yeah.
Okay, ya. Betul ada letakkan lagi. Okay,
Okay.
lagi.
Scroll down. Scroll down.
Okay, terus sekarang. Okay.
Okay. Scroll down.
Okay,
Yeah.
Ismail.
Yeah. Okay. Okay. Good. Good.
Uh,
Good. Good. Good.
so
Yeah.
basically, Ismail, there is 32 oil sample from the oil spill event. So
Mm.
basically, there are 94 compounds such as an alkane, biomarker. So we cannot know how can we classify this oil spillage. So
Mm.
basically, they are using the PCA and HCA as we learned from the lecture just now. They
Mm.
by using the PCA and HCA, they can group the sample into four cluster, which is
Okay.
diesel, heavy fuel oil, mixture oil, and the waste oil. So
Okay.
basically, from my understanding, by using this PCA, we can cut the cost and we can cut the analysis time compared with using the conventional methodologies. That first part. Okay, for the second part, okay, basically when we study about the oil spillage, we want to know how can we improve this oil spillage. So basically, so doctor, can we move up to page 3? Okay.
Okay. Okay.
So
Good.
basically, page 3 by Ghanem et al.
Okay.
Scroll to the okay, okay. So Ghanem, so basically, how we want to remediate this oil spillage? There are many methods we can do. As from this graph lah pie chart above, basically as we can see, the bioremediation 38% we can use to encounter this oil spillage. So they study by the Ghanem et al. On by Ghanem et al. They using the bioremediation, which mean using microorganism to take up the oil spillage. Okay, so by using the box banking, they can find the highest or optimum condition to degrade this oil spillage. So basically, from my understanding too, by using this chemometric, we can know the optimum condition for our experiment. That's all from my understanding. Is it correct, doctor?
Yeah, correct, correct. Yeah,
Okay, okay.
yeah, good, good. I think you have good reading on this paper. So look, good example from three of you today. I think you can understand well now because you can relate with your work, isn't it? So There are methods of how to optimize our experiment. There are the method of how we can classify our sample. There are methods on how to generate our data set. There are methods on how we can um, generate the property of our sample. For example, viscosity, sulfur content, and many more. All right. Good discussion from all of you. As mentioned here, maybe you can read for experimental design, or we call it in our lecture later. We call it response surface methodology. These are example of experimental design. Packet movement. Yeah, we have many more, but the packet movement is quite advanced. Yeah, we have simple one. I will introduce you as a general subject in this chapter, in this code. Only a basic one, not packet movement. But packet movement is one of the good experimental design method that you can implement. Okay. So is there anybody would like to say something before we stop our class today?
It is totally new for me.
Good. Tell me.
Yeah, it is totally new for me because whatever I'm working with is a pharmaceutical industry.
Yeah.
It is already established, already the R&D already developed the method. So
Yeah.
based on this paper, I just want to try, doctor.
Yeah. Yeah. Good.
Okay. Characterization of pharmaceutical solid state.
Which paper?
Characterization of pharmaceutical.
Characterization. Okay. Good. This one. Yeah. Okay.
On page 552.
552. 552. Wait. I want to reduce. 552. Yeah. This one.
Okay. Based on just I'm not sure whether I'm correct or not, because
Yeah.
in pharmaceutical we producing or manufactured a very high quality product because we injected to the patient. We want a very we don't want to sell a very low quality product.
Yeah.
So in this paper, they are using a chemometric by using PCA I'm not sure, PLS.
Yeah.
Okay, one of the requirement is the stability of the drug product or drug substance, or
Okay. Good.
API. So in this paper, they are using that chemometric method to see the shelf life of that API.
Okay.
Okay, so for example, we claim that that product can withstand for about 3 to 4 years.
Okay.
So using this method, they will see stability, meaning that whether it is degraded or not until that shelf life.
Good.
Okay, that's all from me. Thank you.
Good. Yeah. Yeah. So degradation time. Yeah. Degradation time, or the quality of what we are talking about, is the property of interest that we can use chromatic to predict. So I can say that in this case, um, uh, chromatic method can be used to model the shelf life of pharmaceutical compound, or pharmaceutical ingredient, for example. Yeah. So they use chemical structure here, whereas the chemical structure of studied API are distributed in figure 7. This one. Yeah. Okay. Good. Good feedback from all of you. I feel very excited to see all of you again in next year. Yeah. Okay. So that's all for today, class. It is 9 o'clock already. You can WhatsApp me if you have any question. Again, I will maintain my idea or my method like this in the future. In our next class, I will use 1 hour for presentation, and we take a break for 1 hour reading paper. And for the next hour, in the future, in the next class, I will use this kind of discussion, or I will introduce you of how to use MATLAB for chemometric methods. Okay. So that's all for today. Until we meet again in our next class. Goodbye. Assalamualaikum warahmatullahi taala wabarakatuh. Good night, everybody. Happy New Year.
Thank you, Doctor.
All right.
Thank you, Doctor.
Dadah,
Thank you,
Happy New
Doctor.
Year.
Happy New Year, Doctor.
Bye bye.